Okay guys, this is it. This is my last video. It's kind of sad, I have to say. Um, so what is this that you're looking at? You're looking at essentially I would say like a practice test, but I took different like questions from different years that match up with the different types of questions. So it's just I wanted to give you new questions that you had not done in your packets, that's something that was a little fresh for you. So what's very, very important, guys, is when you're doing this, is please, please, please do not just watch me do it. Like that is not, we're past that, guys. Like that's old. You have to try each problem individually. Try your best. Push yourself like you will in the test. Push yourself. Really try. Don't give up and just watch it, guys. Try, try, try. And when you've done everything you can do and you're just like, I just don't know what to do, then you can watch. And even when you watch, you want to pause, and once you get it, and you're like, oh, okay, I get it from here, then do it from there. But don't just depend on me. Okay? Is that clear? The birds have flown the nest. You gotta fly alone now. Okay? It's the end of the line. You understand what I'm saying? Okay. Otherwise, watch Stand and Deliver. That's all I can say. Watch Stand and Deliver and call it a day. Okay? All right. Oh, and you get points for this. You know that, right? Okay, we're gonna make this I'm gonna try and make this the best damn video I've ever made. It's my last one. I'm going out with a bang. Here we go. 2013 number one calculator question. We'll talk about the question type in a second. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by this function, where t is measured in hours uh, from 0 to 8. Right, that's what that means. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel. That's important. So at the beginning, I have 500. Okay, that's important. We're going to kind of underline that. During the hours of operation, 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. So you have to have like some like English language um, knowledge of the vocabulary. Like what's it saying? So it's processing the gravel at this amount. So it's going in unprocessed and then it gets processed. What a weird question, eh? What a weird question. This was, by the way, a fun fact. 2013 test. This is my test. 11 years ago, I sat and took this test. This exact question. So funny that 11 years later, I am doing it again. This is a rate in, rate out question, by the way. Okay, let's do A together. Okay, so hopefully you've tried it, because I think A is very, very gettable. We want to find G prime of 5. Using correct units, interpret your answer in the context of the problem. There's two parts to this problem, 2 points. G prime of 5, what does that mean? Right? It means take the derivative of G at 5. Don't go taking it by hand. You got a calculator. Let's use it. I'm reduced to a TI-83, guys. I mean, this is the state we're in. But you know what? This is proving to you, you don't need some fancy color calculator to do these problems. Anyone can do them. Most important thing though, just make sure right now before the test, you're in radians. I'm gonna try and get you some extra batteries, just in case. But yeah, make sure you're in radians. Okay. Y1, 90 plus 45 cosine uh, x squared divided by 18. We're just going to close that off. Make sure that looks good. 90 plus 45 cosine x squared over 18 looks good to me. And we're going to math 8 that, right? Math 8 is derivative, so we're going to do y. Oops. Get away from that. Oops, my bad. I gotta wait for it to do its thing. There we go. And then, yeah, I'm confusing because I can't do that on this calculator. Y vars function, y1, comma x, comma 5. Negative 24.588. So one thing, guys, like when you're on the test, you don't want to you never want to lose points because of how you write something. And so you always want to write things very, very specifically. Don't just write this number. Repeat the question back to it. It says find g prime of 5. Let's answer the question. It says find that. Let's answer it. G prime of 5 equals negative 24.588. Let's take a second right now to do the units. So the units here were measured in um, tons. It looks like tons. Yeah, tons per hour. I should have underlined that earlier. So if that's this rate, then the derivative is measured in tons per hour squared. Okay. So now we got to interpret that. So whenever you think of interpretation, you want to think of nut. Okay. Nut. Number, unit, time. Number, unit, time. Number, unit, time. Okay. So we're going to say at, this is time, t equals 5. That's my t. What is this saying? The rate is not this, right? When we prime it, we're talking about the rate, but the rate is not this. That's the rate. G of 5 is G of whatever that is. This is saying the rate at which uh, unprocessed gravel arrives is decreasing by 24.588 tons per hour squared. Is that clear? Let's make sure that's clear. So there's a nut, the t is the 5, the unit is tons per hour squared, that's the number, and the interpretation is just saying like this is not the rate, it's the rate of the rate. So we say the rate is changing, is decreasing by this amount. Okay. One thing I want to emphasize, and maybe I'll take a second right now to go through this little handout which I gave to you in class. If it's relevant, I'm going to bring it out. This is it right here. So in the example, this person says the rate at which gasoline is flowing into the tank is decreasing at a rate of negative 0.005 gallons per second. But that's wrong because you can't be decreasing at a negative value. See this one, it's positive. So one important thing is when you write your sentence, this is not negative, even though it's negative here. You are accounting for that negative by saying decreasing. That decreasing is kind of the negative. Does that make sense? Okay. Find the total amount of unprocessed gravel that arrives in the plant during the hours of operations on this workday. So if you watch my notes video, whenever you want asking for like a quantity, you're thinking integral. Like get that in your head. Quantity is the integral of a rate. So we're just gonna, if we want the amount that arrives during the hours of operation, well, it's just 0 to 8. We're gonna take the integral from 0 to 8 of g of t dt. I don't know if they would take off points if you did absolute value, but there's no need to do absolute value. That's like a total distance kind of question. That's not relevant here. Okay, so let's do it. Math 9, y1. I by the way, just a fun fact here. I never knew about y1 until like when I was even in college. I don't think I used y1, which is probably crazy to you, but I didn't. I just like had to type it back in. Oh dear, that was a mistake. So we tab the integral 825.551 always 3 decimals, and then we'll go ahead. It doesn't specify units, but we'll go ahead and put it. So that'll be tons. So basically, that many tons arrived from t equals 0 to t equals 8. It's not it's not specified that I explain it, so you don't necessarily need to write the sentence. I'm just doing it to help you. But you don't need to put that. Is the amount of unprocessed gravel in the plant increasing or decreasing? So when you whenever a question is asking about increasing or decreasing, you should immediately be thinking about derivative. Like this indicates to me, okay, derivative, right? Derivative positive, increasing. Derivative negative, decreasing at time t equals 5. Okay. But I want the amount. So obviously I want to take the derivative of the amount. Does that make sense? Is the amount of gravel in the plant increasing or decreasing? Well, if you just think about this, right, you got gravel going in, right? Gravel is going in, gravel is going out. You basically need to know, is there more gravel going in or is there more gravel going out? Right? So we're going to take the gravel in at 5, G of 5, that's the gravel in, right? And we're going to subtract the gravel out, which is 100. That was in the question right here. See, it's processing at 100. So we're going to take the gravel in. This is the in, right? Minus the out. And if this value is positive, then more is going in, right? And if this value is negative, then more is going out. So we need to find G of 5, which remember you just get from y1 parentheses 5 is 98.141. So it's 98.141 minus 100 equals negative 1.859. So we can say, so again, whenever you do FRQs, you have to answer the question. Is the amount of unprocessed gravel in the plant increasing or decreasing? We would just say it back to it. The amount of unprocessed gravel is decreasing at t equals 5 because g of 5 minus 100 is less than 0, right? And so like, I think maybe some of you might make the mistake of like, you might ask, oh, is the rate at which gravel is entering increasing or decreasing? That's a different question, right? If it's asking, is the rate increasing or decreasing? That's when you would take the derivative of this. But this is just asking, is the amount increasing or decreasing? And that's why it's just this. Does that make sense? I hope that makes sense. Okay. Last one, D. What is the maximum amount of unprocessed gravel at the time at the plant during the hours of operations to justify your answer? So this is a candidates test. So maximum amount you think candidates test. So we're gonna have our little integral here, and we're gonna have our times. So we're gonna have the endpoints 0 and 8, and then we'll have our quantities. So we'll have like Q. We'll call it Q of t. So we're going to make a new function up called Q of t. And Q of t is going to be a quantity at a specific time. I talked about this in the notes, guys. So a Q of t is going to equal an initial value, which is in this case 500, that was in the question, plus the integral from 0 to t of r of x, g of x minus 100 dx. Okay, you might be confused with the x and the t. The x and the t is like, I could just switch. This is the gist. Okay. So that's my quantity equation. So at 0 I'm at 500. I know at 0 I'm at 500. At 8 I can figure 8 out, but I also have to get my other values here. You have to figure out when the derivative is 0. So we have to set g of t minus 100 equal to 0, or that's the same as saying where does g of t equal 100, and that's at, if I put 100 in y2, let's try to zoom 0 this. Oh, this doesn't look good. Let's see what happens here. Okay, so that's the rate at which gravel is entering. Oh, that's my critical value there. So we're going to second intersect. So zoom 0 is a nice little way to get this to look pretty easy, pretty quickly rather. 4.923 is that t. So that happens at t equals 4.923. That's my critical value. So it's going to go here, 4.923. So you set the rate in minus the rate out, that was this right here, equal to 0. You get where that equals t, and basically you're now plugging you need to plug the 8 and the this into that. The 8 and the this into that. Okay? All right, let's do it. So we're going to have stake mass 9 of y1 minus 500, sorry, minus 100 from comma x comma 0 comma 8. We'll add 500. So it's 525.551. That's how much there is at the end. 525.551. And then we'll do it at uh, at 4.923. So instead of 8, we'll change that to 4.923. Close it and add the 500. Yeah, this one's bigger. 635.376. 635.376. So what is the maximum amount? The maximum amount of unprocessed gravel is 635.376 tons. Okay? And that's good enough. Like, this is your justification. So your justification is via the table. Okay? So let's look at the answer. You just make sure we did a stunning job. So yeah, you get a point here for the derivative, which we got, and then the sentence is another point. The integral, writing the integral is a point, the answer is another point. So guys, just try something. They just did this one slightly differently. They just basically said, okay, well the rate in is less than the rate out, so therefore it must be true, but my way works fine as well. This is what I'm talking about. So they made their like quantity function, they just used different letters than me. And then they set the derivative equal to 0, and they got there the same time as me. And then they did their little candidates test like I did, and then they said the same maximum. Okay, that's it. Okay, I hope you're feeling okay about that one. That's a rate in, rate out. If that wasn't clear, it's a rate in, rate out. All right, we got a little area problem. 2015 number 2. You know, you probably did this question at some point, like some practice test or some point in time. But it's just good review, and like based on like the predictions are saying that there will be an area volume FRQ. Who knows? And it could be a non-calculator version, but who knows? So let f and g be functions defined by f of x equals 1 plus x plus e to the x squared minus 2x and x to the fourth minus yada yada yada. Let R and S be the two regions enclosed by the graph shown in the figure above. Find the sum of the regions of R and S. So use a calculated question, which is great. By the way, this is area volume. Area volume. That's the question type. Okay. So let's go ahead and put it in. So we're gonna get 1 plus x plus e to the x squared minus 2x. Close it, and then we'll get x to the fourth minus 6.5x squared plus 6x plus 2. And we'll zoom 6 that. Okay, just like to get us started. So I can see, I'm kind of paying attention right now to like which one's which. And I saw like the one that was drawn first. If I just click trace, I can see which one's which. That this kind of U one. So let's like zoom boxes so we can get a little bit of a better picture of what's going on. So I'm just gonna make a box so I can see everything a little bit better. Zoom in a bit. Just gonna zoom in there. Although sometimes it's nice to have the x-axis showing so you can. Here we go. So we can see, and I now have something that looks pretty close to what I've got up here, which is nice. And I can just confirm, okay, that this function here, the u, is the 1 plus x plus e to the x, and the other function is the x to the fourth. So let's label them now, just so I don't forget that. That this right here, this is my f of x, and this up here is my g of x. Okay. Now let's go ahead and get this intersection point right here while I'm at it. So the intersection point is going to be second calc intersect Drag it over here, and then enter, enter. It's gonna be 1.033. Okay, so this is 1.033, or however you want to label that. Okay, so I've done all my kind of setup. Now I'm ready to find my get started with the problem. Find the sum of the areas. So I want the area of R plus the area of S. So we're just gonna integrate. We're gonna take the integral of the top minus the bottom. So it's gonna be the integral from 0 to that number I found, 1.033, of g of x minus f of x dx, plus the integral from 1.033 to 2 of f of x minus g of x dx. That's it. So, I mean, if it was a no calculator question, this could be the end of it, or they might, if it was like simpler, um, yeah, if it was simpler functions, they could make you take the antiderivative. It was no calculator, but in this case, we do this in the calculator, right? So we're gonna go math 9. So the first one, I gotta make sure I know which one's which. So my y1 is the f of x, right? Yeah. So I'm just gonna label this for my sake. I'm gonna keep writing as f of x and g of x when I'm here, but in my calculator I gotta know which one's which. So it's gonna be uh, y1. No. That one is my fx. So it's gonna be, sorry, y2. Nope. Vars function y2 minus vars function y1 comma x comma 0 comma 1.033. Close it. So the area of my first region is 0.997. It makes sense. I'm getting a positive number. Looks like I did everything right. Plus, and we'll do the other integral. And we'll just flip these around. So vars y vars y1 minus vars y vars function y2, and then from 1.033 to 2. Okay, and we get 1.007 roughly. 1.007, and so add them together, you get point plus 0.997 is 2.004. That is the answer I got. And if we look at this, same exact thing. 4 points for that. The limits, the integrands, meaning like the insides need to be right, and the answer. So, you guys got, I believe that 100% you can do this question. 100%. B, the region S is the base of a solid whose cross-sections are square from the volume of the solid. So you just have to know the formula for the volume of the squares, or the area of the squares. So you're integrating S, so you're just going to integrate from 1.033 to 2. And then it's going to be this second one here, so of f of x minus g of x. And because it's a square, you're going to square that value. And that's it. That's all you got to do. So I can try and just reuse what I just did here. And then what I'm going to do is I'm going to go back on this integral, and I'm going to insert some parentheses here by doing second delete. Insert some parentheses, and then I'm going to insert a little square here. A square. Okay? And so that's going to square the term, and so I'll get 1.283. That is it. So again, 3 points for that. Do you think I got that in high school, guys? I don't know. Who knows? Let h be the vertical distance between graphs of f and g in region S. Find the rate at which h changes with respect to ax when x is 1.8. So again, this is the key word, the rate. It could also be like, is the rate increasing or decreasing? And then you have to know what vertical distance is. So h of x just means like top minus bottom, right? The vertical distance at for region S, I'm just going to keep it in the right order, top minus bottom. So it's going to be f of x minus g of x. And so we're gonna do like h prime of 1.8 equals f prime of 1.8 minus g prime of 1.8. And then we're just gonna put this in the calculator. Okay. I wonder if there's something related to this in this handout. Yeah, this is kind of what I'm looking for. So right here, the graph of k is concave down at the point where x equals 4 because k prime of x less than 0, versus the graph of k is concave down at the point where x equals 4 because k prime of 4 is less than 0. That's what I'm trying to emphasize is here, that you can't, you have to say truths, if that makes sense. Like h prime of x is not going to equal this answer. We're putting in the 1.8. If my output is a number, there better be a number in here. You see what I'm saying? So it has to be true. Make sure what you're saying is true. Okay, so let's do it. We're gonna math 8, and then the function, I can just do y1 minus y2 is my function. Do y1 minus function y2 comma x comma, and the value is 1.8. Done. Negative 3.812. Okay. And we can see here that that is the correct answer. Okay, same exact thing. Okay. Hope you're feeling okay about that one. Yeah, maybe give yourself like a number out of 5. How you're feeling about it. This is a good like litmus test for like, what do I need? At this point, guys, if you're doing this, like it's kind of like this is the review. If you were like, I could kind of go over that one like for 30 more minutes, okay, fine. But this is kind of the end, right? If you're doing this, I assume you're doing this kind of on Sunday, maybe Saturday, but it's kind of like the end of the line. This is the last one from 2013. This is 2013 number 2, still calculator 1. I mean, it's easy to see just from the first line that this is a particle motion. Oh, sorry, there's one more 2013 one from my test. Okay, a particle moves along a straight line from 0 to 5. The velocity of the particle is given to us. The position of the particle, s of t. Okay, so that's position. And I know that s of 0 is 10. So this is like I can tell already this is like my starting position. Or like starting point, right? Find all values t in the interval of 2 to 4 in which the speed of the particle is 2. So recall that speed is the absolute value of velocity, which basically means I'm looking for where velocity is equal to 2 or velocity is equal to negative 2. Okay, like when you're looking for where the speed matches, you're looking for where it's both of these. So we're going to graph the velocity, clear these out. We're going to get negative 2 plus parentheses x squared plus 3x, close it to the power of parentheses again, 6 divided by 5, close the parentheses, minus x to the third. They're just trying to trick you with the calculator here. But you have to put that 6/5 in parentheses in the exponent. Okay. We'll zoom 6 this just to kind of get us started. See what it looks like. And so we're looking between 2 and 4 when the speed is 2. So let's change the window, make our x min 2 or x max 4 because that's the window we're looking at. And then I'm going to make my y2 2, my y3 negative 2. That's basically accounting for these two values. And it means like, yeah, I could put like absolute value around this. It's just like, I think it's just hard to do that. I also think the calculator doesn't seem to like that very much. So anyway, here we are. and we can see that it hits it there and it hits it there. Okay, so we're going to get those intersections at 3.128. So basically what we're saying here is like that this is fine. So we're going to get t equals 3.128, and then we'll get the other one. Second calc, intersect down here, enter, enter, enter. 3. Oh, okay, I didn't like that. Let me try it again. Second intersect. Oh, I know I didn't like it. Enter. Make sure your second curve is the right. See how it was go to that curve? I don't want it on that curve. I want this curve. So I do up and down on the D-pad to get that. Enter again. Enter again. And that intersection is 3.473. Okay, and we look at it, and yep, same idea. So solve this, like, which is what I said. Yeah, okay. Write an expression involving an integral that gives the position s of t. So this is what I talked about in the notes guide. Okay, use this expression to find the position of the particle at t equals 5. So the position of the particle is equal to the starting position, which is 10, right, plus the integral from 0 to t of v of, in general, you want to change. I don't know if they would take off points if you did v of t dt, but like I would say v of x dx. You just want these variables to be different, basically, because of reasons. These variables should be different than like these variables. Okay, because okay. Anyway, use this expression. Yeah. So we're gonna find s of 5. And again, I got that. How did I get that 10? I got that 10 from that starting position here because I know that s of 0 is 10. Basically, this is s of 0. Okay. S of 5 would be 10 plus the integral from 0 to 5 of v of x dx, right? And so that would be, let's just be an equal sign here. 10. No. Math 9. Let me show you. Vars, y vars function y1, comma, x, comma, 0, comma, 5, close it, plus, oh wait, plus 10, negative 9.207. And that is what I got here. Okay. Find all times t in the interval 0 to 5 at which a particle changes direction. Okay. So particle changing direction means that the velocity is changing signs. So you have to know that. And I went over that in the notes guide. Velocity changes signs. So I'm going to look, we're looking at from 0 to 5. So let's change our window to 0 to 5. So I'm doing here. And I'm going to be looking, and I'm going to do a little hack here. I'm going to get rid of the 2 and then negative 2, and I'm just going to add 0. That way I can just find the intersection rather than using the 0 function. So, yep, so it hits it there, it hits it there. Yep. So, this is our velocity. So just to walk you through it, basically it's moving to the left here, it's moving to the right up here, and it's moving back to the left down there. If that makes sense. Right, it's going left, then it's going right, and then it's going left. That's how it's going. So where does it change directions? There and there. To find that, you have two methods. You can do 0, or you can do what I just did and like plot 0 as a function, and then you can just find the intersect. It's just easier to find the intersect, so that's why I like it. So that is at 0.536. So t equals 0.536, and intersect t equals 3.138. So again, repeat the question back to itself, right? Don't, particle changes the particle changes direction at t equals 0.536 and t equals 3.318 because v of t changes signs at these points. Okay, let's see what they said. Yeah, so they got the 0 changes sign from, and they sort of said it out loud, changes sign from negative to positive, positive to negative. Therefore, the particle changes sign. Yeah, I mean, they're basically saying what I'm saying. I just didn't specify which way they change signs, but my answer is fine. Okay. Is the speed of the particle increasing or decreasing at times t equals 4? So again, this is one of those things you need to know. The speed is increasing or decreasing. I need to know the velocity and acceleration. So we need to find out what v of 4 is, and you need to find out what the acceleration is. So we need to find out that v prime of 4 equals a of 4. And what does that equal? So one thing I want to note too, and this was in that that little guy that knows. Let me find where I saw this. Yeah, right here. So I want to note right here. Although this is the correct answer, credit will not be given since there's no setup as requested in the question. I'm sure that's what it says. See the difference between these two questions? This one's just saying, oh, acceleration is this. But this one's saying that the derivative of velocity is acceleration, which equals that. Do you see the difference between these two? So see here, I'm saying velocity at 4 is this. I can't just say a of 4, right? I have to say v prime of 4 is a of 4, which equals, which I'll get in a second. So v of 4 I can get by just going vars function y1 parentheses 4, that's v of 4, negative 11.476, and then a of 4 would be math 8, right? We're going to take the derivative of y1 comma x comma 4, and it's negative 22.296. Negative 22.296. Okay. So I can say that the speed of the particle is increasing at t equals 4 because v of 4 and a of 4 are the same signs. Okay, good. All right, those are the calculator questions. We're on the no calculator portion now. Okay, no more calculator. That's great. I don't want to deal with this TI-83 anymore. Okay. All right, so this is obviously what kind of problem is the table. So again, if you're following along with me right now, take a second, go, do this problem, try it. Again, this is from 2013, my test from 11 years ago. You got a table, you got T, you got minutes, you got some ounces, okay? Hot water is dripping through the coffee maker, filling a large cup with coffee. The amount of coffee in the cup is given by these amounts, so there's like some ounces and there's more ounces later, right? It's given by a differential function c, so it's kind of interesting, where t is measured in minutes. Selected values of c of t are measured in ounces given the table above. Okay, so use the table to approximate c prime of 3.5. Show the computations that lead to your answer and indicate units of measure. Very common question. Where is 3.5? It's right here between these two. So we're going to get the a rock there. So we're going to do c of 4 minus c of 3 over 4 minus 3. That is 12.8 minus 11.2 over 1. which you could leave like this, by the way. You don't have to do this, but that's just, I hope we could, it's 1.6. So again, leave it unsimplified. Don't worry about it, and indicate units measure. So it's going to be ounces, and then we're just going to divide by the the other unit. So whatever that is, you just divide by it, ounces per minute. Okay, that's it. Good. Is there a time t? Classic MVT problem. I would definitely expect to see this on the test, guys. Expect this. Is there a time t between 2 and 4 at which the derivative of c is 2? Justify your answer. So if you watch my notes video, you know that when you're given a function and it's asking what the derivative of that function, if that exists at a point, that is mean value theorem. And if you just want to nab a point, you can get a point just by getting an AROC, finding an AROC in this interval that equals 2. So if we look at the interval 2 to 4, I can see that I see one, right? So from 2 to 4, we go up 4, right? And we go over 2. Well, that's our average rate of change of 2. So I'm going to write that. So I'm going to say C of 4 minus C of 2 over 4 minus 2 equals 12.8 minus 8.8 over 2, which equals 4 over 2, which equals 2. That should get me 1 point just for doing that, because this is an average rate of change in that interval that equals that derivative. This is proving mean value theorem, but I have to then I have to justify it. So I say, because C of t is differentiable, it tells me that, differentiable right here, is differentiable, therefore continuous, right? And the average rate of change from t equals 2 to t equals 4 is 2. There must be a t on 2 to 4 such that c prime of t equals 2. I'm kind of like repeating it back to itself. If that makes sense. You have the condition here. You're basically telling them what you found here. I think you could really just show this. But the condition part is important, and just saying, okay, well, since that's true, then there must be, if we're repeating it back to it, there must be a t from 2 to 4 such that this is true, at which that's true. Let's see what they said as just a counter argument. So they did say it's differentiable and continuous. They did find that average rate of change, which I said you get the point for just getting that. And then they just said, therefore, by the mean value theorem, there's at least one time t in that interval for which that is true. So we basically said the same thing with different words. And I guess the key parts that you want to hit are the condition, the average rate of change, and then just saying, so it's true. That's basically what this is saying. Repeating the question back to it and saying it's valid. Okay. Use a midpoint sum with 3 subintervals, let's underline this, of equal length indicated by the data table above to approximate the value from 1 of 1 over 6, 0 to 6, c of t dt. Using correct units, explain the meaning of that in the context of the problem. So 3 subintervals from 0 to 6. So of even lengths. We're going to go from 0 to 2, 2 to 4, 4 to 6. What's the width of all of these? It's 3. It's 2, 2, and 2. And if it's a midpoint, that means we're multiplying it by the middle value here. So we're going to say that that this 1 over 6 integral 0 to 6 c of t dt is approximately 1 over 6 times 5.3 times 2 plus 11.2 times 2 plus 13.8 times 2. And I can just leave it like that. That's fine. So I did approximate it. and then using correct units, explain the meaning of it. So this is, you have to recognize that that is average value, right? That is the average value. So it's saying, um, I can just say this is the average ounces of coffee in the cup from t equals 0 to t equals 6. Okay, that's what it means. You have to understand that it's average value. Um, yeah, basically the same thing. They did the simplified. I just left it unsimplified. That's fine. It's the average amount of coffee in the cup in ounces over the time interval 0 to 6 minutes. Okay. So the last one is the amount of coffee in the cup in ounces is modeled by B of t equals 16 minus 16 e to the negative 0.4 t. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So something like, so again, rate. You see the word rate. It's changing. And t equals 5. It's derivative, guys. It's derivative. It wants a derivative. We need to find b prime of t. So derivative. Derivative of 16 is nil. Nothing. The derivative of negative 16e to the negative 0.4t. Don't freak out, guys. You got this. It's going to stay the same because it's e. So it's negative 16. That's a constant multiplier. It's going to stay. E, the derivative of e stays the same. E to the negative 0.4t. But then you have to multiply by the derivative of the inside. So we're going to multiply this by negative 0.4. Done. That's it. That's all it is. So the negatives will cancel here. So b prime of 5 equals 16 e to the negative 0.4 times 5 times 0.4. All I did there was cancel out those negatives. I mean, if you were confused by that, just leave the negatives in there. This is fine. I don't need to go any further. I could simplify this more. I'm not going to because I don't want to make a mistake and lose points. Don't simplify. Do not simplify. Um, it doesn't say to specify. It doesn't say to specify the units, but the units would be ounces per minute squared, assuming that all the units were the same, because it's the rate of a rate. Um, Sorry, I made an oopsie here. It would not be minutes per squared. It's the amount of coffee. The derivative of the amount is just ounces per minute. That was my first mistake. Oh, I was gonna be perfect. No. Uh, okay. Anyway, here we go. Yeah, exactly the same thing. We got ounces per minute because it gives you quantity. Derivative of quantity is just divided by time. Okay. All right, 2 more to go. We're out of here. Well, I'm out of here. You are very much still in the study zone, unless you're not. All right, here we go. 2017, number 3, no calculator. A little bit more recent. This is a graph analysis, right? You're given that derivative. Something again I want to emphasize to you. This isn't one of those problems, but something I really want to emphasize to you is I really think you're going to get one of these where it won't say f of x. It'll say this is like f of x, and it'll say, okay, g of x is the integral from like, I don't know, like 3 to x of f of t dt. And you have to basically say, oh, okay, the derivative of g of x is f of x. I'm just like, this is not the question, but I'm telling you, I think that's going to be your question when you get this on the test. I think it's going to give you f of x here, and I think it's going to give you the accumulation problem, and you have to take the derivative. You have to do this immediately, basically, and identify, oh, okay, this is just a derivative of this. This is always a derivative, guys. Always this is a derivative. Okay, maybe I put like a little caveat on that. Seemingly it's always a derivative. Just expect this to be the derivative and just make sure you're ready to do this. But this is not one of those problems. This problem is it's already knows it's a kind of easier problem. I already know this is a derivative that makes things easy. It's a differential function on negative 6, 5 and satisfies that f of negative 2 is 7. Okay. The graph of f prime, the derivative of f consists of a semicircle and 3 line segments as shown in the figure above. Find the values of f of negative 6 and f of 5. Okay, so to find f of negative 6, this is like the whole initial value kind of problem. I need to take my my first value, which is f of -2, and then I'll take the integral from -2 to -6 of f prime of x dx, basically, right? And so, and then same idea for f of 5, right? F of 5 is going to be f of -2 plus the integral from -2 to 5 of f prime of x dx. You're taking the initial value and you're adding the integral of the rate from where you started at to where you want to end at. Okay, so f of -2, I know that is 7, so this is just 7 here, and this is going to be 7 here, right? That's just 7. It's given to me. The integral from -2 to 6. So -2 is here, -2 to -6 is this area here. That area is 1, 2, 3, 4 by 2. So the area of this is 4, right? 4 times 2 divided by 2 is 4. But because I'm going backwards, I have to subtract that. So it's going to be, this becomes 7 minus 4, which is 3. Okay, this one is going forward, so I don't have to worry about that. But it is a little more challenging. It's this region here, which is, remember, this is pi, the area of a circle is pi r squared. So this is pi r squared over 2, and the radius is 2, so it's 4 pi over 2, so it's just 2 pi. So this is a negative 2 pi right here. And then this little one, what is this? This is a 1 by 2, so this is a 1 right here. And this is a 2 by 2, so this is a 2. So 3, so this is going to be 10, 3, because 7 plus 3 is 10. This whole thing together is 7 minus 3, sorry, 3 minus 2 pi. So it's 10 minus 2 pi. Okay. So with these, given the rate, you got to find values. You do the initial value plus the integral of the rate. You get the area to get that integral, and you got it. Let's see how I'm doing. Yep, looks good. That's three problems, 3 points there. On what intervals is f increasing? So f is increasing when f prime is positive, so it's going to be from -6 to -2, and from 2 to 2, 3, 4, 2 to 5. So we say it back to it. F is increasing on -6, -2, and 2, 2, 3, 2, 5, because f prime of x is greater than 0 on those intervals. Okay, let's take a second to look at that no-no sheet again, just to reiterate this. I'm looking for something relevant. Alright, I mean, I don't see anything exactly matching this, but yeah, this is correctly written out. Let's like just for a second talk about like other places what f is doing. So f is increasing here because f prime is positive. F is increasing here because f prime is positive. F is decreasing here because f prime is negative. F is concave down from -6 to 0, and from 3 to 5 because f prime is decreasing. F is concave up from 0 to 3 because f prime is increasing. F has a relative maximum at -2 because f prime is 0 and changing from positive to negative. F has a relative minimum at x equals 2 because f prime is 0 and changing from negative to positive. F has an inflection point at 0 and at 3 because f prime has relative min and relative max at those points. So what I just did there is I was basically in my head going through the function analysis chart. And so if you really know sorry, I'm just trying to look for my function analysis chart. If you really know the function analysis chart, you're able to do that, right? You're able to just be like, okay, I know, sorry, I found it. If you really know this chart right here, You don't, you're like, I'm able to look at a graph and I can name every single one of these conditions, no problem. So if you truly know this, if you're truly ready, you can look at any graph of a derivative and you can tell me everything about f and justify it. Right? That was, I believe, one of your questions in the Unit 2 test. That was a long time ago. So refresh your memory on this. Okay. All right. Find the absolute minimum value of f in the closed interval -6, 5. Justify your answer. This is a candidates test. Whenever you see absolute minimum, candidates. So -6, 5. So my candidates are gonna be -6 and 5, and we're gonna have to count -2 and 2 because that's where, I guess I should say that. So I want to see where f prime of x equals 0, and that's at x equals -2 and x equals 2. Like let's get those points if I can, if that's all it is. Like that's it. So -2 and 2. And then I'm going to plug that into this function here, right? This is this function. So this is a capital. This is the f of x there. So do I already know some of these? Yes, I do. So I already know f of -6 is 3. That was given to me. Or I found that earlier. And I know that f of 5 is 10 minus 2 pi. And I know that f of -2 is 7, because that's given to me. Okay, so I just need f of 2 right now. F of 2, I'll do that over here, is that 7 from before plus the integral from -2 to 2 of f prime of x dx. And I know that already from -2 to 2 is just -2 pi. So that's just -2 pi. So the answer is -2 pi is the absolute minimum. Okay, on, -6, 5. Okay. Let's make sure I got it. Uh-oh. No, I didn't, because I forgot to do the 7. Ah, another point lost. Jeez, guys. 7 minus 2 pi. Ah, it's two mistakes. I was too cocky. Yeah, 7 minus 2 pi. Because I forgot to include that 7 here. I just jumped to the -2 pi, but it's 7 minus 2 pi is the position. -2 pi is the displacement, the change, right? But I have to include that initial value. That's why that was 7 minus 2 pi. So this answer is 7 minus 2 pi. Okay. For each 5, f double prime of -5 and f double prime of 3, find the value, explain why it doesn't exist. So f double prime of -5 just means get the slope at -5. 1, 2, 3, 4, 5. So I just need the slope of this right here. So slope is going to be, what is it? This is the right. So the it's -2. F double prime of -5 is down to over 4. So it's -1/2. And f prime of 3, 1, 2, 3. It's a corner. So I'm going to say it does not exist. F prime of 3 does not exist because limit as x approaches 3 left of f double prime of x does not equal the limit as x approaches 3 from the right of f double prime of x. And if you look at the answer key, that is what they're saying. They're just using like a different form of it. That's just a derivative. Yeah. So that's basically, I'm saying that the derivatives aren't matching there. The slopes are not matching because of that corner. Okay, so that's 2017-3. We're in the last one, guys. Well done if you made it this far. Very well done. This is a differential equation. Okay, you can see it here. Got a slope field. I hope you get a slope field question because they're so easy. A slope field given by differential equation shown below. Sketch the solution curve that passes through 0, 2. So again, you just follow the lines, very easy. You guys are good at that. And then same thing here. We're just gonna follow it up. Something like that. Okay. Good. Okay. Let f of x be the particular solution to the given to the differential equation with initial condition f of 1 equals 0. Okay. Write an equation for the tangent line, to line tangent to the graph at y equals f of x at x equals 1. Use your equation to approximate f of 0.7. Okay. So as soon as you see that, you say, okay, y minus y1 equals mx minus x1. And we're going to plug in, okay, so I know my x1 is 1. That's given to me here. I know my y1 is 0. And then I just need my m. And so then to get the m, you just plug in these points into the derivative up here. So, I mean, I can say dy dx at 1 comma 0 equals 1/3 1 times 0 minus 2 squared. That's 4/3. So I can now rewrite it. It's going to be y minus 0, so just y equals 4/3 x minus 1. And then we're just going to plug in 0.7 for x. So y equals 4/3 0.7 minus 1. Okay? And if you need to get y alone. So if you had a term over here, you'd have to move it over to make sure you get y alone. Let's just make sure we're doing good so far. Yep, so we got that nice. That looks pretty good. 4/3. And yes, I didn't simplify it, but that. Oh, I guess one little thing that I would say not a good thing that I did, probably a mistake, is this should not be a y. This should say f of 0.7. So I think like a key thing, repeat it back to it. It says it wants me to approximate f of 0.7, so my answer should be f of 0.7. Repeat it back to it. That's my bad. It's my bad, guys. Sorry, just bad. That's bad. Okay? Answer it how it asks it. It wants that, answer like that. I hope they would have given the points for that, but honestly, I don't know. I kind of think not. So answer it as they ask it. Find the particular solution to y equals f of x to the given solution. So this is like the big problem, right? This is like the 5-pointer. So you write it out, dy dx equals 1/3 x y minus 2 squared. And we want to separate the variables. So you're going to multiply left by dx, right by dx. You can divide this by y minus 2 squared. Divide that by y minus 2 squared. And you get dy over y minus 2 squared equals 1/3 x dx. The antiderivative of the right side here, then we're going to anti-differentiate both sides, is going to be x squared over 2, right? So it's going to be x squared over 6 plus c. Okay, and then on the left here, now be careful. This is not ln, right? It would be if there was no 2 here, that's ln. If there was a negative right here, that would be negative ln. But this is ln. That's not ln. To to anti-differentiate that, you have to rewrite it in the numerator. So it's like um, I might do it like off to the side and I'll come back down. Really, it's y minus 2 to the negative 2, negative second, right? So we add 1 divide. It's going to be y minus 2 to the negative 1 over negative 1. So that's the same as negative 1 over y minus 2. That is, like, this is how that works. So okay, you start with negative 2, you add 1 and divide. Negative 2 plus 1 is negative 1. Divide by negative 1. That comes down to the numerator. You just make the whole thing negative. Where this is kind of irrelevant. Like I could put it out, like kind of out here, but leave it in the numerator. And so that's it. So this is negative 1 over y minus 2. And then we're going to solve for c. So we're going to f of 1 equals 0. So it's going to be, I'm doing it over here. So we're going to say negative 1 over 0 minus 2 equals 1 over 1 squared over 6 plus c. So this is just 1/2 minus a sixth equals c. A half minus a sixth is 2/6, or that's a third, equals C. So then you come back here. I'm going to need some paper. I guess this will work. We're going to rewrite it. -1 over y minus 2 equals x squared over 6 plus 1/3. Um, your goal is just to get y alone. This is like kind of a hard algebra problem. To get y alone here, you multiply both sides by y minus 2 by y minus 2. So that cancels, that cancels. You get -1 equals x squared over 6 plus 1/3 times y minus 2. Then you're going to divide both sides by x squared over 6 plus 1/3 x squared plus, over 6 plus 1/3. And then you're going to have, then that's going to cancel with that. And then you'll add that 2 over. So you get y minus 2 equals this. Basically right now, 1 over x squared over 6 plus 1/3. And the last step is just plus 2 here cancels. And this is your answer right here. Okay. Let's make sure we're good on that. Yep. Yep. Yes. The only thing is like there's a little bit of simplification difference between us, but it's the same thing. Yep. That's it. Okay. So congrats, guys. I mean, that was a 2018, by the way. You guys got this. I'm super, super proud of you. You've done so well this year. I hope you're feeling decent about it. And no matter what, it's all good, guys. You did your best, and that's all you can do. And you've made big growth, and I'm super, super proud of you. And I'm going to miss you guys a lot when you're gone. And I'm really, really happy about how this year went. So just do your best, and that's all you can do. All right. I will see you on Monday morning at breakfast. And until then, it's goodbye from me. Okay, goodbye. I was gonna do a face reveal then. Hang on, alright, alright. Oop, oop. It's it's goodbye from me. Oh, hang on. There we go. Hey, alright, it's goodbye from me.